He is also the executive director of Green Island Cement Company Limited. He is a chartered accountant, and currently he is also the current chairman of the Hong Kong Construction Material Association Limited. Yeah. What I can say is he is a very senior executive and with excellent professional in the construction materials. Today, we are very glad to have his sharing. His topic, he will share with us about the concrete sustainability from cradle to cave. Welcome, Eddy. Yeah. So about the blessing. Yes, please. Thank you.
Okay, good afternoon, everybody. Thank you, Phoenix, for inviting me to be the speaker in the afternoon. Now, Phoenix, I'm not too sure the background of the audience, but I will try to speak in very simple language about the current situations and about the our Hong Kong futures in relation to carbon neutrality in 2050. Now, in the next 25 minutes, I'm going to cover the current situations in Hong Kong, our challenges in Hong Kong, our opportunities in Hong Kong, and the way forward. How can we minimize our carbon footprint and CO2 emissions? Now, what are the most widely used construction materials in the world? Now, there are two types. Number one is steel, which I think Professor Tsang has covered. The other is concrete. Concrete, again, just now, Mr. James Yields has actually covered some of the topics on concrete. Now, I'm afraid to say that both steel and concrete has a big carbon footprint, unfortunately. But unfortunately, the two construction materials are not 100% replaceable nowadays. Talking about steel. Now, the steel manufacturing process. In the steel manufacturing process, we use a lot of coking coal. We use a lot of limestone. Now, in the principal ingredients of both coking coal and limestone, by itself, the material itself, because of the calcifications of the limestone, now it produces CO2. Unfortunately, this steel manufacturing process, which we manufacture a lot of steel bar, they account for 8% of our global carbon emissions. Now, of course, we talk about green bars a lot, but then when we want to secure or procure green bars, unfortunately, green bars comes from scrap steel. Scrap steel, say, for example, Hong Kong, like, for example, a lot of construction company ask for green bar. But unfortunately, all this green bar comes from Turkey, the gas furnace. Now, unfortunately, nowadays, may not have enough supply of scrap steel. Therefore, we may not have enough supply of green bars in Hong Kong. Now, this is number one, is steel. Steel accounts for 8% of the global carbon emissions. The second one, we are talking about concrete. Now, what is concrete? Now, people mix up a lot about cement and concrete. Cement and concrete are two different things. Concrete is cement plus aggregate plus water plus admixtures. Now, when we talk about, James just now talked about concrete, but the principal carbon footprint of concrete actually comes from cement. Now, cement actually accounts for 7% of all global carbon emissions. Now, if we can use less cement, meaning that the concrete will have a lower carbon footprint. So the problem by itself is, how can we use less cement in the concrete manufacturing? Now, I am a cement manufacturer. Now, the way I'm looking at it is just like I'm floating stone into my own lakes, or 將石頭抌自己一腳, because I'm a cement manufacturer and I'm encouraging people to use less cement. But unfortunately, this is the global trend. Now we have to face. Now, so if you use less cement in concrete, meaning that our CO2 emissions will go down. So it is very simple. If we can design, just now, James was saying, if we can have design some sort of concrete, now in the specification, we specify less cement, use some other materials, then we will have a better carbon footprint in the concrete and in our construction cycle. Now, how can we produce low carbon concrete? Now, what is low carbon cementitious material? Now, nowadays we are talking about only two raw materials which we can replace cement, and they are also cementitious material. Number one is the PFA, the fly ash. Number two is Professor Tsang is talking about GGBS. The full name is ground granulated blast furnace slag. Now you can look at the screen. They look very similar, except that GGBS is whiter and also is more finely grounded. Now, talking about PFA. PFA in Chinese, 粉煤灰. Now, it's a byproduct of the coal burning, it's a byproduct from coal burning power stations. Now, in Hong Kong, it comes from two main sources, either from Lamado, Hong Kong Electric in Nama Island, or in China Light and Power. They've got Castle Peak Power Station, they've got Black Pond Power Stations. Now, they are extracted by static precipitations, meaning if you study physics, it's positive and negative, and then all the fly ash will fall into the bottom. It has been widely used in Hong Kong for a long period of time. When I say long period of time, it has been used by us for about over 15 years. Now, unfortunately, PFA's got the limitations. Now, the limitation is in terms of the replacement percentage. It's very commonly used in Hong Kong is about 25% replacement rate ratio. Only, it cannot go beyond 25%. But in certain circumstances, with the proper use of admixture, we will be able to use PFA up to 35%. But this is really the limit. This is the maximum we can use PFA in replacing cement. Now, always remember, if you can replace cement, meaning that the product will be better and have a better carbon footprint. Now, unfortunately, now if you look at the Hong Kong government planning, I mean, we want a bluer sky, and therefore we've got a plan about 10 to 15 years ago. Now, if you look at the diagram, now in 2015, 48% of our electricity comes from coal-firing power station. But in 2020, our coal-firing station in Hong Kong is generating 24% only. Now, in 2023, when the L12, L13 engines in Hong Kong Electric commission, the ratio of the power generation using coal will be getting less. So meaning that the PFA actually comes from coal-firing power station. Now imagine if we use more natural gas and more nuclear, meaning that the supply of PFA in Hong Kong will be very limited. So in the government blueprint is now in the future, hopefully we will not burn coal in generating electricity. Okay, so the problem is we will not be getting enough fly ash in Hong Kong by the two power plant in Hong Kong. Now that's come to GGBS. What is GGBS? GGBS is a byproduct from blast furnace during steel making. When I say steel making, don't misunderstand. I mean, when we talk about steel mill, they've got two types of steel mill. One is a steel mill with steel manufacturing, and their products maybe is pig iron. They use all the limestone, coking coal. And the other type of steel mill that maybe we have got in Hong Kong is rolling mill. Rolling mill in Chinese is 扎鐵廠, 扎鋼廠. Steel mill with blast furnace, we call it 煉鋼廠. You have to distinguish when we say, oh, okay, steel mill. It's actually two different types. Now, GGBS comes from 煉鋼廠 during steel manufacturing. Now, the chemical composition of molten slag is actually, to a certain extent, is quite similar to cement, but they don't have the cement hydraulic properties. They are calcium oxide, silica oxide, aluminum oxide, and magnesium oxide. Okay. Now, this is a process of how we manufacture GGBS. Now, actually, GGBS is a byproduct. In the blast furnace, all the more heavy steel will go into the bottom. The molten steel will go into the bottom. On the top is all the molten slag, and the molten slag, after quick cooling, it becomes the ungrounded GGBS, but ungrounded. And then we use this GGBS and grind it into final finished products. And then this final finished product will deliver to the concrete plant. Hopefully they will be able to specify in their concrete mix design. Now, actually, in using less cement, even the benefit of using PFA or GGBS, now, for example, especially for GGBS, we can produce more durable concrete. The reason why we can produce more durable concrete is now because one thing is the packing density of GGBS is finer than OPC, the cement. So imagine if it is very, very fine, what we call that they will fill up the voids in the concrete, meaning that the packing density is higher. When the packing density is higher, the benefit of higher packing density, meaning that it will reduce chloride ingress. Now, we have heard, I don't want to talk a lot about the concrete here. Maybe some of the audience have heard of course, James have heard of what we call the ASR effect, aggregate alkaline reaction. Now, we call it concrete cancer. Now, it can reduce the chloride attacking the concrete. Number three is increase the sulfate resistance. Again, is producing more durable concrete because the density is higher. And the other thing is when we're working with concrete, now I'm sure most of you are not concrete workers, if you've come across and talked to a concrete workers, they can tell you. Now, when they are pouring concrete, the temperature can be up to 93 degrees. Now, if we can use more, like PFA has got the same physical properties and chemical properties as well. They can actually reduce the heat of hydration. Now, when we say we can reduce the heat of hydration, meaning that we will be able to prevent certain, what we call thermal cracking. So to us, as using GGBS, they've got lots of advantage. Not only because it will have a better carbon footprint, it's also more durable, reduce chloride ingress, increase the sulfate resistance, and also can reduce the heat of hydration. Now, just now, I've talked, you produce, using GGBS, we produce low CO2 concrete. It will meet all the environmental targets. Also, GGBS, if you are not used, it will be going to a landfill. Now, just like a PFA. Now, if the audience, some of the audience are old enough, you realize that Hong Kong, for Hong Kong Electric and China Light and Power, they used to have ash lagoon in Hong Kong, but we, Green Island Cement, I don't want to do any marketing, but then we use up all the ashes in the ash lagoon. Now, the concrete produced using GGBS, of course, they got a lower embodied carbon. And also, now imagine, now, when we produce cement, we use limestone. Limestone is the natural resources. So if we can reduce cement, meaning that we can reduce mineral extractions. Now, GGBS is not a new product. It has been around for 150 years in Europe, and it has been used in the US about 100 years ago. So GGBS is particularly good for use in ball power, and I can guarantee that they will be able to meet all the flow, bleeding, strength development, if the proper admixture is used in the concrete mix design. Now, I have mentioned just now, I mean, it's not a new product. In Singapore, we are using about 1 million tons of GGBS. In Taiwan, we are using about the same amount of GGBS in Taiwan, but not in Hong Kong at the moment. Now, the beauty of GGBS is now, I have just mentioned, especially for marine works, because it can reduce the chloride ions attack and also the corrosion resistance against sulfuric acid, which is what we are happening in the seawater. There are lots of chloride and sulfuric acid. And also the beauty of GGBS, now PFA is good, but GGBS have got one better properties over PFA is in the replacement percentage. Now for GGBS, we recommend customers, and also we are seeing that in all the literatures that the initial, remember, PFA, we are talking about 25%. Now, for GGBS, the starting point, we are talking about at least 35% replacement, and can be up to 75% replacement of cement. Remember, using less cement, meaning less CO2 emission. So we can, if we can replace 75% GGBS with cement, now imagine the concrete that we produce using 75% GGBS will be, I can say, very green concrete. Now, but we will not recommend to those two extremes. We recommend maybe 45% to 65% replacement. Phoenix, I'm watching out for the time. Okay, now for the concrete strength, this is a bit technical, but then just to tell you that for both PFA concrete and GGBS concrete, when they compare with 100% what we call OPC, ordinary Portland cement concrete, they are more or less meet all the requirements. Besides, the 28-day strength, with what we call the latest strength, is actually better than OPC concrete. Now, I've talked about GGBS, and then I go back to why cement produce a lot of CO2. Now, the carbon footprint of OPC stands for ordinary Portland cement. Okay, Portland is a town in the UK. Anyway, now, when we produce cement, most of the carbon actually comes from the raw material. Raw material is limestone. Principally, 1 ton of cement, about 86% or to 88% is limestone. When you say limestone, people, you have all seen limestone before. You have been to Guilam, Shandong. You have been to Turkey. I mean, they have got lots of limestone caves. Those are the limestones. But unfortunately, limestone, the principal ingredients of limestone is calcium carbonate. Now, you don't need to understand chemistry, but it's CaCO3. CaCO3, when they decompose in the our precalciner or calcification of raw material, when it comes to about 900 degrees, it will decompose. It's just adding and subtracting. CaCO3, when they decompose, becomes CaO and CO2. And that's where the CO2 come from. The principal CO2 is actually come from the limestone. Therefore, the steel manufacturing process and the cement manufacturing process, they've got a big carbon footprint. It's principally coming from the limestone. Okay. The other part is, of course, we use coal, and also the Scope 2 emissions. We are talking about finished grinding, we use electricity. So for 1 ton of cement we manufacture, we actually produce 850 kilograms of CO2. So this is a generalization only. So different cement plants have got different yardsticks. So I'm saying that most of the cement plant nowadays is between 750, maybe up to 950 kilograms. But for PFA, because it's a waste material, and GGBS because it's a waste material. Now comparing with the carbon footprint is PFA is only 13 and GGBS is 60. Now I'm watching out of time, so I quickly go through the last few PowerPoints. Now this is a ternary system. It's getting a bit technical, but just to let you know that the more CaO, the earlier strength is better. The more silicon oxide, the later strength is better. So from this triangle, the ternary system, you can tell that now if we can replace cement with PFA or GGBS, actually the later strength is better than the OPC. Now, this is some sort of data, but just to let you know that now for grade, what we call grade 45, grade 60 concrete using GGBS and PFA, actually the 28-day strength has actually, they are well above the requirements. So we don't need to worry about the strength of PFA or GGBS concrete. Now, just to let you know that now this is the practical example. Now, if we can replace cement with 25% of PFA, we can reduce 19% of CO2 or 67 kilogram of CO2 per cubic meters. Now, for 45% replacement with GGBS, we can cut down 37% or 131 kilo of CO2 per cubic meters of concrete. Now, to a not very extreme, but 60% GGBS, we can cut down 52% of our carbon dioxide emissions or 186 kilos per cubic meters of concrete. Now, quickly go through the remaining. Now, Hong Kong, they've got, not talking about the future northern metropolis of artificial island in central waters. Normally, we've got 6 million cubic meters of cement each year. Now, if you've got zero substitutions, we will be using 2.7 million tons of cement. 25% PFA, if we can replace 25% of PFA, now the cement consumption will be cut down to 2 million. Now, if we can replace 50% of GGBS, our cement consumption is only 1.35 million. Okay, changes start with all of us. Now, all of us meaning that the developer, government, consultant, everyone, workers, everyone. We have to, just like before James was talking about, we have to engage all the stakeholders to the picture in order to be successful. Now, this is more or less the last PowerPoint I have to share with all of you. Now, before, no one talk about ESG. No one is interested. There's no incentive to go green. Now, because now the carbon neutrality 2050 is a hot topic in town, then we will focus on this area. But unfortunately, up to now, I have to say the owners and some of the consultants are too conservative now. Now, I have an analogy. It's just like a restaurant is very famous for deep fried oyster. Now, there's a customer going to the restaurant. He didn't order, but then he asked the manager, now, what do you recommend? He always recommends deep fried oyster. Now, but actually, steamed oyster is on the menu for a long time. So, but no one bothered. So the customer is every time he visits this restaurant, he is having deep fried oyster as recommended by restaurant owner. But then now things have to be changed. Actually, steamed oyster is better than deep fried oyster. It's more healthy. Now we need the customer, meaning that the private developers, the government, when they visit the restaurant, they know how to order in the menu. It's actually in the menu. GGBS is in the government general spec for 20 or 30 years already. It's not something new. So the government or the private developer has to talk to the managers that I want to order steamed oyster. And the restaurant owner have to recommend the customer, now, steamed oyster is more healthy. So, and the chef, of course, the chef actually knows how to make steamed oyster, even though he's cooking deep fried oyster every night. So this is one of the problem with Hong Kong at the moment. But I think things are changing now. Now, the concern is the restaurant owner's concern is only about setting time and the early stream. But from the example I've shown you that their concerns is actually can be minimized by using proper admixture in the concrete. Now, the last problem is the silo limitations, because in Hong Kong, land are expensive. And for some of the existing concrete operators, they may not have space to accommodate another silo for GGBS. Okay, Phoenix, I think more or less I have covered all my topics. Unfortunately, I've got 5 minutes overrun. Thank you very much for all the audience, and hopefully for the last 30 minutes, if you are expert, hopefully you reinforce your way of thinking about all the low carbon cementitious material. If you are not so familiar with the topic, I hope that you will be able to learn something from my presentation in the last 30 minutes. Thank you very much, Phoenix.
Thank you, Eddy.
And the audience.
Yeah, thank you, Eddy. You are a professional lecturer. You give all the audience a very concise and easy understand concept.
Because I don't know the background of the audience. That's the problem.
For me, I learned a lot. Maybe I can conclude is you have, being a manufacturer of concrete, you have started change to low carbon.
No, I'm a manufacturer of cement. No, don't mix up cement and concrete. James is a manufacturer of concrete.
Oh, okay. You're manufacturing of cement, and you have already started change.
Yes.
That you are asking all the other stakeholder, the customer and the consultant and the owner.
Yes.
Yeah, to make up
together.
To make up their mind to adopt the change. I think
exactly.
This is your very clear message, and your message is very important. And important is you are very important in terms of carbon emission.
Yes, I am.
Yeah, okay.
I am. No doubt.
Yeah.
As a cement manufacturer, now we are actually producing carbon dioxide. Now, if you got a chance, come and visit our plant, and I show you more details about what environmental initiative we have taken to lower our carbon emissions.